The owner of 2 fast food restaurants has recorded customer satisfaction ratings for both locations on a scale of 1 to 5, and the table below summarizes the information. So here we have ratings, we have restaurant A, and we have restaurant B. First thing we want to do is calculate the mean for both restaurants. So let's start with restaurant A, and let's just move restaurant B over here out of the way. Okay, so the rating is going to be X, and we have to get P of X. P is the probability. Remember, I said that the probability is basically the relative frequency. So we need to sum all of our frequencies up. And you can do this on notebook paper. I'm just doing it in Excel, but anything that I do, you could do on paper and use your calculator. So now we're going to get P of X. And the way you do that is you take, just like you do your relative frequency, you take your frequency and divide it by the total number of frequencies, or which is N. It's the total of the sample. So there's the first one. And then you're going to do this for each one. Divide it by 80. And so those are our probabilities here. Now, what we need to do next, expected value, you take X times P of X. Remember, expected value is the mean of a discrete probability distribution. So this is going to be Xi times P of Xi, and a lot of times I just don't mention the I, but it is there. It's just, it identifies the index of the data values. Not really a big deal as far as doing the formula. So you're going to do Xi, which is your rating, times your probability. And you're going to do that for each one. You're going to do 2 times 0.1750, 3 times, just like we've done before. I'm doing this in Excel because it makes it a little bit easier. And then remember, after you multiplied X times P of X, you just sum that up to get the mean. So there is my mean for restaurant A, 3.663. So we are rounding to 3 decimal places. Now I'm going to do the same thing with restaurant B, and I'm going to calculate this. I'm going to pause it and I'm going to calculate it, and I want you to try to calculate it. Pause it and try to calculate it on your own, and then check it with mine. So the first thing you need to do is sum your frequencies and then get the relative frequency, which is the same thing as the probability. So divide each one of these by 75. And I went to check, and it does say round to 3 decimal places as needed. So we are going to round our probability to 3 decimal places. Okay, and then you're going to multiply your rating, which is this column, times, which is X, times P of X. And so I did that, and then I got my sum. So that is my mean. So this is the mean for restaurant B, and this is the mean for restaurant A. So now let's look and see what we have to do next. It looks like the next thing we need to do is the standard deviation for restaurant A and the standard deviation for restaurant B. Okay, so what I have done to get the standard deviation, we have this variance formula down here, but it does go on to say to get the standard deviation, take the square root. So I'm going by that formula, and if I were you, I would get used to kind of understanding everything in the formula with it, and that will help you work this quicker and have a better understanding. So it says I need to square my xi values, or I'm just putting x, but I'm squaring xi, which are your ratings. And I see that I have lost some way I lost my ratings over here. So I'm just gonna, what I'm gonna do is, here are my ratings. And let me see if I can get this. Okay, here we go. So here are my ratings. I'm gonna highlight those. That's when I'm squaring. That's X. Okay, so if I square that, I can do that in my head. 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. I'm going to go ahead and put those in over here too because the ratings are the same. 1, 4, 9, 16, and 25. And I will upload this spreadsheet. So if you want to practice using it, or just practice making these columns on your paper. It's very important to stay organized when you're working a problem like this. All right, so x squared times p of x. So here's x squared, and then I would times that number by p of x. And you could do that on paper in your calculator. Okay, so I'm going to copy those numbers down. All right, and let's look and see. For standard deviation, we are rounding to 3 decimal places. Okay, so I've done x squared times p of x, so I need to sum that. I'm looking at my formula down here, and it's telling me I need to sum after I multiply those. So make sure you put equals sum parenthesis and then highlight what you want it to add. If you don't want to use Excel, you don't have to. So there's your sum. So now what I want to do is I want to take the sum that I just got and I want to subtract my mean squared. And I don't have to put parentheses around the mean squared because it's going to follow order of operations. Okay, so there's my standard deviation. And 3 decimal places would be 1.274. Okay, so let's check that. Oh, I have one more step. I have to take the square root. So one more step equals the square root. And what you can do is put square root at the beginning of this and take the square root of that. And so that would be 1.129, which is, you can be off a little bit. You can see the answer tolerance down here and still get credit for it because they do allow for a few different numbers because of rounding. All right, let's look at the second one. All right, we're going to do x squared, which is right here, times p of x. I forgot to put times. Okay, so I'm just going to copy that formula down. I'm going to sum that up. I'm doing it a little bit faster now that we have seen one worked. Okay, so that's the sum. Now remember, you take the sum, which is 10.32, you subtract the mean squared, so to the second power, and I want to take the square root of it because I want to get it all done. And then I'm going to round it to 3 decimal places. Wrong way. So I get 1.423. Okay, the last part says what conclusions can be drawn from these results. Well, restaurant A had a higher average than restaurant B. Okay, but the standard deviation the smaller it is, the more consistent it is. And so since restaurant A's standard deviation is smaller, the data is also more consistent. And so this problem will take you a little extra time just because you're having to do, it's really 2 problems in one. So let me know if you have any questions. I'm going to put the spreadsheet below the video.